Okay, in this video, I'm going to go over multiplying by 1 again, except this time I'm going to use an example from using formulas, okay, rather than just a regular equation that really just has numbers and variables in it. Now, you might recognize this particular formula as the area of a trapezoid. Okay, remember what a trapezoid is? It looks something like this. And a trapezoid basically has two uneven sides and then two parallel sides. Not the best drawn there, but you get kind of the idea. So it's an irregular shape like this. Now, what do each one of these particular variables mean over here? So in the parallel sides, we're going to call one of these the base, and it really kind of depends which way you turn it upside down or not, right? So we'll just call this base sub 1. That doesn't mean times 1. Doesn't mean it's an exponent. It's just a way of saying it's a base, but it's the first base, and that's the one that we're going to call it. And one that's parallel to it, we'll call just base sub 2. Now, remember, the reason we call them both bases is because it really depends on your view of the trapezoid, right? You could just take this and turn it upside down, and then that could be the first base and the second base. So this is just a way of designating the different bases. Now, the height of a trapezoid is really just the distance between the two bases. So let's just do something like that, all right? And that's just going to be the h. And that way it's consistent no matter where you put it between these two bases. So that's what the h is, all right? And then capital A is usually what people designate as the area of anything that you're looking for. So area of a triangle, square, that sort of thing. Okay, so let's get back to the problem. Now, in this particular problem, we are going to solve, okay, for, let's say, base sub 1. So let's say we want to find this particular length if we know all the other variables. Now, let's assume, just to show you how this multiplying by 1 thing works, that we don't even know those numbers, but we want to just isolate the b sub 1. Okay, so get it to where the a is and then put everything else on this side. That way we can just plug numbers in. So here we go. Let's go ahead and start our process. There's step 1. There's step 2. Remember, when you're multiplying by 1, usually a good first thing to do is to make everything on one side all additions and subtractions. Okay, now if we look at this over here, looks like we've got a multiplication here, we got a division there. So we want to make everything additions and subtractions. We want to separate it into individual terms. So the first thing I'm going to do is I'm going to go ahead and distribute the h to both of those top two terms, the b1 and the b2. So I'm going to get h times b sub 1 plus h times b sub 2, all divided by 2. Okay. Now look what I've done here. I've got two different denominators now, right? I've got a denominator here and I've got a denominator here. And now you can legitimately ask yourself, how can I make both of these denominators the same? What's the common denominator? And the common denominator would be 2, isn't it? And this is where the multiplying by 1 comes in. I'm going to multiply this side by a 1, but the 1 is going to be 2 over 2. Now, this denominator is 2 and this denominator is 2, and this side is proportionally larger. Remember what we said with multiplying by 1. Once you've actually got the same denominator, you can cross them out. And now in the third step, I'm going to rewrite cleanly what's left up here. And I've got 2 times a is equal to h, the height, times b sub 1, plus h times b sub 2. Okay? We're getting closer. Now notice that everything is in additions and subtractions. You know, remember, this is just a term, or individual terms, right? Even though it's a multiplication, that you treat this as a single term. A term, remember, is everything between additions and subtractions. So that would be a term, that's a term, that's a term. Now remember, I'm solving for b sub 1. So I'm going to subtract now this term from both sides. So let's do that. This will go away. And in my step 4, I'm going to have 2a minus hb2, and that's going to be equal to hb1. Now look how close we are to being finished here. The way you get rid of this h, so we can get b sub 1 all by itself, you always do the opposite operation. So if it's multiplication, you're going to divide now. So let's go ahead and divide by this side by h. And remember, you got to do the whole side by h. Over here, that's going to cross out. Step 5. Final answer is going to be 2 times the area minus the height times the base sub 2 all over the height. And that's going to be equal to b sub 1. Now, that could be your final answer. This is perfectly acceptable. What I found, though, is some people are tempted to cross out those two h's, right? And you can't do that. The reason you can't do that is because this denominator belongs to both of these terms in the numerator. So what I'm going to do is I'm going to write what's called an equivalent form or an equivalent answer. Remember, equivalent just means the value is exactly the same. It's just in a different form. So let's go ahead and do that. Let's separate this h so that it's the denominator for both of the terms. I'm going to say 2a over h minus h times b2 over h. That's also equal to b sub 1. This is an equivalent form. The cool thing about this, though, is now I can cross those h's out because I'm not crossing this one out here. It still belongs to over this 2a, but I've crossed it out for this term. So a third equivalent form would be 2a over h minus b sub 2. So this answer, and this answer are all the exact same thing. They're all equal to b sub 1. Okay, I hope that was helpful to you. If you have any questions, let me know.